Greetings everyone, and today we are going to discuss about electric dipole. First, let us discuss about the basic definition of electric dipole. Dipole is basically the separation of opposite electrical charges which are having the same magnitude but opposite uh, charges. It is quantified by an electric dipole moment. Electric dipole moment associated with two equal charges of opposite polarity separated by a distance d is defined as a vector having a magnitude equal to the product of the charge and distance between the charge and having a direction from the negative to positive charge along the line between the charges which is the axis between the two charges. Now in this case we can represent this condition in P is equals to Q into D, which means that here dipole moment is the vector product of charge and displacement, and charge and displacement in between the two charges. Now in this condition there are conditions that both charges should have the same magnitude but their uh, signs can be opposite. Now, electric field due to positive and negative charges can be explained in such a manner that here we are having a Coulomb's law application. That here, as we know, that there are two electric fields generated. As these are point charges, these point charges generate two electric fields. Now, there are 2 point charges having same magnitude, so both generate electric field. Now, both of these are having electric field, which is equivalent to 1 upon 4 pi epsilon naught q upon r square, 1 upon 4 pi epsilon naught q upon r square, out of which when we are going to further decide and solve it, we will have our equation in such a manner that here, as you can see, that uh, electric field of charge of a positive charge and electric field of a negative charge can be given in such a manner that electric field of a positive and negative charge is equals to E sin theta plus E cos theta. Electric field of a negative charge is E negative sin theta, E plus E negative cos theta. In that case, E negative sin theta and E negative cos sin theta are cancelled. E negative and E positive sin theta are cancelled with each other, while E negative and E positive cos theta do not cancel with each other because both are parallel to each other. In that case, both are parallel to each other, due to which both do not cancel with each other. E sin theta, E negative sin theta, E positive sin theta are cancelled with each other because these are perpendicular. So cos 90 is equals to 0. So in that case, uh, these are not cancelled. Apart from which, when we want to put both of these values, a value of value of electric field of positive charges 1 upon 4 pi epsilon naught q upon r square, and plus 1 upon 4 pi epsilon naught q upon r square. Now in this case we are gonna utilize a formula. We are gonna utilize a method that here r square plus d upon 2 whole square will be the condition. Here r square plus d upon 2 whole square will be added. Why? Because here uh, r square is considered as, for suppose this is the dipole, these are two charges, this is the dipole generated, this is the electric field of charge 1, this is the electric field of charge 1. Both are having same magnitude but opposite charges, same magnitude but opposite charges. This is electric field of charge 2, electric field of charge 2, electric field of charge 1. Now basically the distance or the axis which joins their center is this, while the distance, which is half of the dipole, can be written as y, while this is point charge q, negative q, positive, both having same magnitude. And here this can be considered as a radius distance, and on the other hand side this is the complete diameter. This can be considered as the complete diameter of the charge, the axis between the two charges. Now half of the diameter can be written as d upon 2, right? On the other hand side, uh, an angle is formed from an angle is formed. Now as you can see, this dipole is having electric field on in this direction, and another dipole which is negatively charged is having electric field on the other direction. Now in that case, if we are supposed to uh, resolute it into its components, then we can break it into its component in such a manner that here 1 over 4 pi epsilon naught r square can be broken into two components. One is r sine theta, r cos theta, r cos theta, r sine theta. Similarly, the of the vector components of vector are a displacement vector of q negative charge can be written as r sine theta and r cos theta. In that case, r cos theta, r cos theta are similar, parallel. They do not cancel with each other. R sine theta cancel with each other of different uh, charges. In that case, this is how we do it. After which, what is d upon 2 here? D upon 2 is the distance, so we are gonna d upon 2 is the radius itself, so we are gonna add it on both sides. So d upon 2 whole square plus d upon 2 whole square is written over here. Now we are gonna take common of both of these values. The common of both of these values can be taken, and accordingly the manipulation will lead us to 1 over 4 pi epsilon naught 2 q upon r square plus d upon 2 whole square cos theta. In that case, uh, cos theta is equals to d upon 2 upon r. How are we are supposed to calculate it? That here cos theta is equals to d upon 2 upon r. Cos theta is equals to d upon 2 upon r. D upon 2 upon r, which means here cos theta is equals to half of the radius. Cos theta is equals to half of the radius because the force is acting in this direction. Force is acting over here. Force is acting over here. So in order to calculate it, it is equals to d upon 2 upon r. And in that case, this is how we do it. Apart from which, we want to also cos theta is a thing, we do it over here. Now d upon 2 upon r can be written in the form d upon 2 or d upon 2r. When we are gonna put the value of d upon 2r, we'll have an equation as this. But here, before calculating putting the value of d upon 2r, we will put the value of r. That in order to calculate r from its rectangular components, we know that here r is the we know that here, as you can see in the diagram, r is the hypotenuse, y is the perpendicular, and d upon 2 is the base. So when we are going to take the Pythagoras theorem of this equation, that will turn out as radical r square plus d upon 2 whole square. This is the equation how we form it when substituting the value of d upon 2 upon radical r square plus d upon 2 whole square. The equation will become as 1 upon r f square 4 pi epsilon naught 2q upon r square plus d upon 2 whole square. D upon 2 upon the radical r square plus d upon 2 whole square is equals to 1 upon 4 pi epsilon naught qd upon r square plus d upon 2 whole square 3 upon 2. In that case, qd is equals to dipole moment, which is then kept inside the value. So as the value of dipole moment is kept here, so we know that value of dipole moment is kept over here. So value will be becoming as uh, E is equals to 1 upon 4 pi epsilon naught P upon R square 3 upon 2. 3 upon 2, 1 upon 2 was because of the radical, and 3 was because of the cube over the R. So here it becomes as P upon R square 3 upon power 3 upon 2. Now when we are going to further manipulate it, answer will become 1 upon 4 pi epsilon naught P upon R cube, due to which this will be the final equation for our answer. So that's all about today's video. Hopefully we'll meet again in another one.